Hello and welcome. Recently I was talking to somebody and it's something I hear common. People think that administrators or these, companies that run these servers have your passwords. And maybe they do if they're doing things improperly, but your password should never be stored on a server somewhere. It doesn't need to be. Companies, admin, your IT guy at your local work should not know your password. There's no need for them to ever know your password. It should never be stored in a database somewhere. If that's so, then how does a server check your password when you send it to a server to log in? Well, it all comes down to sums, checksums, and today we're going to be looking at md5sums and sha256 a little bit, and I'm just going to try to explain the basic concepts behind them. And I am not a mathematician. I am going to try to explain these in very simple manner, and hopefully everything I say is somewhat accurate even if it's simplified. If I say something completely wrong, be kind, but comment below, let me know. Just don't be mean to me about it, right? Because I'm not a mathematician. But what is a sum? Basically, it takes some information and it will add parts of it together and come out with an output. Now, recently we've been talking about encryption and encoding. Well, a checksum is different, right? So the main difference is it's a one-way math problem, okay? So encryption and encoding are usually some sort of math, but they can be undone, right? With encryption, I can take a message and I can take a key of some sort, a password or passphrase, and I can encrypt it. And I can go back and get the original message as long as I have the key. Encoding is different, like we have QR codes or base 64, or even going to something like Morse code. Morse code is going to be encoding it. So you're taking it and converting it to just a different format. And anybody can undo that if they understand the algorithm of how it was converted. So that's the difference between encoding and encryption. With sums, they are one way. So think about it like this. If you had a sentence or a word, and you gave each letter a particular value, like A was 1, B was 2, C was 3. Again, I'm very simplifying this. And then you take that sentence and you add those values up, you'll get a number. So let's just say ABC, 1, 2, 3. So you have 1 plus 2 is 3, plus 3 is 6. You get the number 6. Anytime you take that ABC and run that math on it, you'll get the number 6. But if I give you the number 6, there's no way to know what the original message was because multiple messages could have that number. Well, that's what a checksum is, except for the math is a lot more complicated in most cases. And so to get two things that have the same output are different. But let's jump right in. I'm in a folder. I can list out some files here, right? I have two text files and a JPEG file. If I was to run file on all of these, file just looks at the header, the first part of those files, and tells me what type of file they are. So the first one is a text file, but it's a Unicode text file. The second text file is an ASCII text file. And then the last one is a JPEG, but it also gives you information on what type of JPEG, gives you a little more information about than just that it's a JPEG. If I was to just copy this tux.jpg to tux.png, and again, I list out the files. List out the files. You'll see, you might think that's a PNG, but I didn't convert it to a PNG. I just renamed it. And I try to point out that for the most part, the extensions on a file are for humans to know what type of file that is. The header, the first part of the data inside that file, tells us what it is. So if I run file on that, even though it's labeled .png, it still knows it's a JPEG, right? And a good image viewer will look at the header, not just the extension. Let me go ahead and just remove that tux.png so we don't get confused. Okay, so now we were talking about sums, right? So I'm going to say md5sum. If you're on a Linux system, this is most likely Ori on your system, right? And I can run that on one or all of our files. So I run on all of our files, you'll see that each one gets its own sum. These are 32 characters, right? And they're alphanumeric, and I'm pretty sure it's not case sensitive. All these are shown up as lowercase. So basically, that means, was it 26 letters in the alphabet? Is it 26? Yeah, I think it's 26. And then you have 0 through 9. So you have 36 different characters to the power of 32. That's how many different possible combinations there are, right? So these are different files. If I was to copy tux to tux2.jpg, and I was to run the md5sum on it again, you can see these are identical files. They may have different names, they may have different timestamps, but the data, the content inside that file is exactly the same. We know it has not been modified, right? Is it possible for two files in the world to have the same checksum? Yes, it is possible. It's highly unlikely. I mean, worldwide, there's probably 2 files out there that have the same checksum, but the fact that you have 2 on your system that have the same sum is highly unlikely. But the main point of this is if I download a file, I can check if I know what the original checksum was, I can compare it. And the odds of someone modifying this file in a malicious manner and it having the same output here is highly, highly improbable, right? So let's say I have an executable file. So I have a program that I send to somebody. For me to modify that in a way to make it malicious and still have the same sum here, it's just not going to happen. There was something not too long ago in the news that there was someone trying to work on that and they were coming up with theoretical ways, but it's still highly, it's not going to happen, right? And same with text files, right? Let's say I'm sending you an important message and it's important that you get the real message, right? It's just highly important that it isn't modified at all. The odds of you changing that text file in a way that it's a malicious message that still seems right and has the same checksum is highly, highly unlikely. Let's look at one of these files. So I have test1 here. It just says hello world, right? If I was to copy test1 to test2.txt and I was to cat out that file to show what was in test2, you can see that it has the same information. If I was to run md5sum on that, on all of this, you can see that test1 and test2 are the same file. They contain the same message. But if I was to open up test2, come in here and just add a space, right? I save that file, save that file and run the sum on it again. Just adding that space gives you a completely different number, or sum. I'm back. I had to leave for a second because my kids were banging on the wall. I don't know if you guys could hear that, but it was very distracting. And I have forgotten where I was. I think I added a space to test2, and it gave you a completely different number. So just adding one character or removing one character in that short little file will give you a completely different checksum. So if the message was meet me at 9 o'clock tonight, and I go in there and change it to say meet me at 10 o'clock at night, it's going to give you a completely different number. So to modify that message in a usable way and still get the same checksum is just not going to happen. Here's a bigger file, right? We have the Wizard of Oz. This is the entire first Wizard of Oz book, which is in the public domain. I can cat that out. It's a big old, it's the entire book. And again, the md5sum will always give you a 32 character sum. If I was to come in here, if I was to copy that again, oz.txt to oz2.txt, and I can run the md5sum on that, you can see same content of file. Again, they can have different timestamps and different names, but the file is the same, the content inside. If I was to go into oz2.txt and come in here and maybe just go down to where it says right here, I'll come up here and say, get rid of this period, right? So it's still the entire book. I just removed one period, right? And now if I run the checksum on that, it is going to give us a completely different number. So this is a way that you can securely check that if you were to transfer a file from one machine to another or a message, is it the same as the original? Now, of course, you'd have to transfer the sum in a different way because if you're getting them from the same place, who knows if the sum that you're getting is the same thing. So I'd have to send you the message in one way and the sum in another. But we know that it's not modified if we securely did that. Now, and that's the content. So again, if I was, let me create a new file. Let me call a file, I'll call it test3.txt. In here, I'm just going to put the number 1, right? So if I cut that out, test3 is just the number 1. And if I was to, again, run, I keep doing sum first, md5sum on test3.txt, this is the content of that. If I was to echo 1 into md5sum, you notice it gives me the same thing because this is the sum for the number 1. Anytime on any machine you're using the md5sum, you will always get this output for the number 1, whether it's in a text file or being sent as message. As long as that is the entire content, there's no other characters in there, this is the sum for that. So what does this have to do with passwords, right? So when you create an account on a website, you submit your password. There are places that will store your password in a database, but they should never do that. What they should do is create sort of sum. They may use md5sum, and again, I'm not like a cryptographer. I'm not a mathematician, but that's one way. Another sum is a sha256, right? And there's different ones of those, and I just type in sha, and you can see I have a few options here. Let's just do the one sum here, and I can run down all my files. You can see here. Let me do md5sum just so you can see. Yeah, md5sum on all of these. So it's running a different math problem on there, right? And we're getting a longer output, but they're completely different. But again, like tux2 and tux are identical files. Same down here, we're getting different numbers because we're using different math, but you will always get the same sum if you're using the same math problem, right? So that's a SHA-1 sum. Let's go ahead and use SHA256. That's going to give you an even longer one. And this is one I believe is commonly used for security, and securing passwords. But again, it all depends on the designer of the website. So what does this mean? So again, if I can echo the word password, right? Let's say my password is password, and I put that into a SHA-256 sum, it will always give me that output, no matter what machine I'm on. So what happens is, this is what should be stored in a database, right? And then I send my password, and when I go to log in, it should never store my password somewhere. Hopefully it's being sent to the server securely, and then it's going to run the SHA-sum on it and compare the output of that, and hopefully never store my password somewhere. Now, there's also some sort of trust there, again, that they're doing things properly, and they're not being malicious. Maybe they're storing your password on purpose, or somewhere for them to check. But they should never store your password in plain text. Now, here's an issue with this, with passwords, right? If password always gives this is again a one way. With this with this sum, I cannot go back. I cannot undo that to say that's password. But people will make things called rainbow tables, right? You can look them up. There'll be 5 gigs, 10 gigs, 50 gig database files, right? And what it is people will just run this on a whole bunch of words, like common passwords and lists of words and combinations of words, and they will create a database. Password equals this. Other word equals this, so this, that. And so even though the math can't be undone, they'll just make a big long list of what each one equals. So how do we undo that? Well, first of all, create a secure password, right? Your password shouldn't be password, something easy to guess, and it shouldn't just be one word. You should, and there's different opinions on how to do this. The longer, theoretically, it's better. So people will put combinations of words, like full phrases, like a cow wearing big black boots, right? You can have that be your password. It's easy to remember, and you can type it out. I also like to throw special characters in there, like maybe if my password is pink hippos, I will put a exclamation mark as where all the eyes go. And then, so if they're making a rainbow table, odds are they going to use that combination of words with those special characters the way I do. But another thing is, websites should add a salt, right? So this is called a hash here, and then you want to salt the hash, right? So you're going to take it and you're going to add some sort of random information on there. So again, password will always give this, but if that website decides to create its own salt, and I don't really know exactly how they do this, I think they could theoretically use your username or your birth date, or just some random information. But just adding, again, the number ones at the end of that gives me a completely different number, right? So they both start off 6B, that's just by chance, right? But then you have, everything else is just different. And that way, even if they know the salt, they would have to create a whole new hash table for that salt. And creating these hash tables is a lot of work. So they would have to go, okay, we're going to attack this site. We have to figure out what their salt is. Now we need to create a hash or a rainbow table with all this information of their salts, which is going to take forever. And then I'm going to have to hope that I generate a password, a list of passwords that matches that person's. And I still need to pull the database. So, but the point here is, your password should never be stored. A company or a person should never know your password. Okay? If you use a password manager on your system, hopefully they're encrypted with a key, and so you still have to type in a password to decrypt it when you go to submit it. But that is what a password hash is. They were using a checksum like this. And again, it has different uses. One is to check make sure a file or message is what it originally was. Another example of a checksum is just to check when something's scanned that it matches, like QR codes do it, but also barcodes, right? There's different types of barcodes, but let's talk about UPC, right? You have all these barcodes, but a UPC, a Universal Product Code, I believe is what it stands for, companies pay for, and that's when you buy groceries or a product at a store, they have their own UPC, they pay for that, and like the first character, I think, is what type of product it is, right? Like, I think 5 is coupons, food products are 0, something like that. And then the next few characters and few numbers are a company like Coca-Cola will have their own, the first few things saying this is a Coca-Cola product, and then you have the product number after that. And then the last number is some sort of sum, to where it takes all those numbers, I think, adds them up, divides them by something, gets the module, which is the remainder, and then that last number, and that's not the exact mathematic problem, but it should match that. So when you scan a barcode, it doesn't just read the numbers, it reads the numbers, does that math, and says, okay, does that last number match what we just added up? If not, then it scanned the barcode wrong, and it's just to check to make sure there were no errors. So it could be used to check errors, to check, make sure there were no modifications. It can be used to store information that you don't want people to know, right? And again, the difference between encryption and encoding, those are math problems that can be reversed, but a checksum cannot be reversed. Again, it's like saying, okay, I'm going to add 1, 2, 3 together gets you 6, but there's an infinite number of variations, combinations that you can add together to get the number 6, right? I could say 100 plus negative 94 would get me 6, right? And so it's like there's an infinite number of options that can get you 6, but it's to check to make sure that what I started with checks out, not that there's no other match to it. But with these, it's hard to make a match on purpose. Anyway, again, I tried to simplify this as much as possible. I hope it made sense. It's fun to play with these, and there's a lot of uses to them. I hope I explained that. And again, I'm not a professional on this. I tried to simplify stuff. I hope everything I said was somewhat correct. And again, if you know more about this subject and I said something wrong, politely let me know in the comments below. But I think the basic concepts of what I said add up. So thanks for watching filmsbychris.com. This is Chris with a K. Check out my website. There's links in the description. I hope that you have a great day.